morning, parents, teachers, and learners. Our topic that will deal on problems involving triangle similarity and right triangles. So we are now on quarter 3, week number 9. After the discussions made in the previous video lessons, it is right time to apply those concepts and skills in solving word problems or real-life problems about triangle similarity and right triangles. Let us be guided by our learning goal or our objective for today. At the end of the discussion, you should be able to solve problems involving triangle similarity and right triangles. Before we proceed to the topic, let us have a review of some related topics that we need for today's discussion through this activity entitled Chain Reaction. You need to read and analyze the following statements that will be flashed carefully. Give the best answer according to the type of question that will be presented. The answers will be used as a hint for the next question. You are only given 10 seconds to answer each question. So are you ready? That's great. Let us begin with item number 1. Let's react. Hit the emoji that corresponds to your answer. The statement, it is a triangle with a right angle. What term is described in the statement? Will you hit heart for equilateral triangle? Will you hit like for scalene triangle? Or will you press wow for right triangle? Your 10 seconds starts now. If you hit wow and answered right triangle, you are great. The next question will deal on right triangle as suggested by the answer. What will be the next question all about? Let us find out. This time, we need to decode the mystery word that will correspond to the correct answer in the given question. A right triangle with equal legs is called blank. Let us use this clue to decode the mystery word. What do you think is the answer to our question? Start decoding. Your timer starts now. If you answered isosceles right triangle, that's fantastic. The triangle is also known as a 45-45-90 right triangle. The chain continues. What will be our next question that will deal on an isosceles right triangle? The next item will be a fill in the blank question type. This time, no clues to decode. The question goes, in an isosceles right triangle, the length of the hypotenuse is square root of 2 times the measure of the blank. What part of the isosceles right triangle are we referring to? 10 seconds, go! If you answered leg, you are awesome! It seems that you can still remember the topic about special right triangles. Chain, chain, chain. What is the next question that will use the hint word leg? Fact or bluff? The question goes, the length of the shorter leg of a 30-60-90 right triangle is half the length of the hypotenuse. Is it a fact or a bluff? Analyze the question carefully. Your time limit starts now. What's your answer? Do we have the same answer? It's a fact. The shorter leg is half the length of the hypotenuse. The chain continues to link questions as we are now to use the hint word hypotenuse. The next question can be answered as fast as you can. Given the length of the hypotenuse in the right triangle below, what is the length of the longer leg? As easy as 1, 2, 3. 30, 60, 90 right triangle problem. Your timer starts now. If you got 6 square root of 3 units, that's incredible. You just need to divide the length of the hypotenuse by 2, then multiply the quotient by square root of 3. We are now on the last chain. How will 6 square root of 3 be used in the next question? Solve. Be ready with your pen and paper. If the legs of a right triangle are 6 square root of 3 units and 3 square root of 3 units, what is the measure of its hypotenuse? I guess you know and mastered the Pythagorean theorem. Just substitute the lengths and do the magic. 10 seconds begins now. What did you get? Let us check if we have the same answer and solution. To solve for this one, we need the Pythagorean theorem. It is given by the sum of the squares of the legs is equal to the square of the hypotenuse. Upon substitution, we will have the square of 6 square root of 3 plus the square of 3 square root of 3 is equal to c squared, as you can see in the screen. Simplifying both addends will obtain 108 plus 27 is equal to c squared. Adding 108 and 27, 135 is equal to c squared is produced. Extracting the square roots of both sides of the equation, we will obtain positive negative square root of 135 is equal to the square root of c squared. Upon extracting, we will now have square root of 135 is equal to c. Note that the positive root will only be considered since we speak about the length of the sides of a right triangle. Simplifying square root of 135 is equal to c by factoring 135 as 9 times 15, hence the final answer is 3 square root of 15 units. That was fun! You did an excellent job in recalling the important concepts that were presented in the previous video lessons. At this point, we will use those skills and ideas as we are about to discuss problems involving triangle similarity and right triangles. How is the topic possible to apply in our daily lives? Let us find out and solve some sample problems. In solving problems involving triangle similarities and right triangles, we follow some steps to make our solutions organized to come up with the correct answers. After reading and analyzing the problem, here are the steps. To remind you, step number 1, identify the given information and illustrate the problem. Number 2, determine the formula to be used. Step number 3, solve for the unknown in the given problem. 4, state the final answer. Remember, answers must be in complete sentence and with appropriate units. Problem number 1 will deal on the trending topic nowadays, which is community pantry. A community pantry is soon to serve the needy people in your barangay. A rectangular table is prepared and set up where the goods will be placed. In anticipation to the overflowing aid, you decided to put a support under the table by putting wooden braces diagonally. If the table is 12 feet long and 5 feet wide, how long is the wood brace needed? Let us identify the given information that we can use in solving this problem. As suggested in step number 1, we are given with the length and the width of the table that are 12 feet and 5 feet respectively. Using the given information, the length and the width of the rectangular table, let us illustrate the problem. So we are asked to find the braces that will be put diagonally. So the question marks represent the length of the diagonals or the wooden brace that will be put under the table. Let us proceed to step number 2. Determine the formula to be used. The length, the width, and the diagonal together form a right triangle. We are to get the length of one of the diagonals with the right triangle formed. The length of the brace is the hypotenuse of the right triangle. Hence, it calls for the use of the Pythagorean theorem that is given by the first leg squared plus the second leg squared is equal to hypotenuse squared. Let us represent the hypotenuse or the length of the wooden brace as h. To continue with the formula to be used and the dimensions, let us substitute the given value. We are now having an equation, the square of 5 feet plus the square of 12 feet is equal to the square of h. Squaring all the terms will result to 25 square feet plus 144 square feet is equal to h squared. Adding 25 and 144 square feet will result to 169 square feet is equal to h squared. To solve for h, we need to extract the square roots of both sides of the equation. Thus, obtaining positive negative square root of 169 is equal to the square root of h squared. Simplifying further this equation, we now have 13 feet is equal to h. And by symmetric property, the length of the diagonal is 13 feet. Note that we only consider the positive result or answer since we are solving for the length of the wooden brace, and the other root will be considered as an extraneous one. Going back to the problem, we are asked to find how long is the wooden brace needed. So the length of one wood brace for support is 13 feet. Since there are two wooden braces that will be put under the table for support, the total length of the wood brace needed to support the table is 26 feet. Have you seen a community pantry in your place? Or have you seen one in the news? Now, let me share a piece of trivia about community pantries during the pandemic. Did you know? The community pantries in Philippines were inspired by a local furniture designer known as Ana Patricia Non. She first put a small community pantry in Maginhawa Street, Quezon City, mainly to help the people in need in this time of pandemic. It comprises of daily necessities such as rice, vegetables, coffee, canned goods, and many more. It became more famous because of the tagline, magbigay ayon sa kakayahan, kumuha batay sa pangangailangan. If you will be given a chance, the resources, and manpower, will you initiate to have one? Will you share what's exists and let others benefit from it? It is for you to ponder. Let us proceed to problem number 2. A 2,500 square meters square farm is to be divided diagonally to separate the cows from the horses. How much fencing wire is needed to divide the farm? 2,500 square meters square farm is the given fact that we need to answer the problem. Let us further analyze and illustrate the problem. It is stated in the given that the square farm has an area 2,500 square meters. We are asked to find the length of the fencing wire that will be set up diagonally. So that is our question mark. To get the length of the diagonal, given the area, first, we need to solve for the length of the sides of the square farm. Let us represent one of the sides as S. Note that a square has 4 congruent angles and sides. Next, let us determine the formula to be used. We need the formula in getting the area of a square, which is equal to S squared, where S is the measure of its sides. After getting the side, take note that the triangles formed are isosceles right triangles, or 45, 45, 90 right triangles. After solving the side of the square, it can now be considered as one of the legs of our isosceles right triangle. Hence, we can use the formula in getting the hypotenuse, which is equal to the length of the leg times the square root of 2. So that is for 45, 45, 90 right triangle. Let us now solve for the unknown in the problem. The first question that we need to answer is how long is the side of the square farm? With the question, we can answer it using the formula in getting the area of the square as given in this part. Substituting the measurements, we have 2,500 square meters is equal to S squared. Extracting the square roots of both sides of the equation to solve for S, we can obtain S is equal to 50 meters. Hence, each side of the square measures 50 meters. After getting the measure of the side, let us solve for the diagonal of the square. Again, we are going to solve for the length of the fencing wire that will be put diagonally. If you can observe, half of the square can form a right triangle, an isosceles right triangle, or a 45, 45, 90 right triangle to be precise, with a given leg which measures 50 meters. The diagonal will be considered as the hypotenuse. Let us use the formula in getting the hypotenuse of a 45, 45, 90 right triangle given by the length of the leg times square root of 2. Let us represent hypotenuse as x. Upon substitution, we will obtain the equation x is equal to quantity 50 meters times square root of 2. By multiplication, we have the final answer as 50 square root of 2 meters, which is the length of the diagonal of the given square farm. To answer the question on how much fencing wire is needed to divide the square farm diagonally to separate the cows from the horses, it is 50 square root of 2 meters. This problem about finding the diagonal of the square farm given its area can also be solved using the Pythagorean theorem. After solving for the missing side using the formula in getting the area of the square, proceed with the Pythagorean theorem. Remember that the sides of a square have equal measurements, which will have the same measures with the legs of the isosceles right triangle. In the previous months, February to April, it is noticeable that there is a surge in the number of cases of COVID-19 and other variants. This surge led to full capacity hospitals within NCR and other neighboring places included in the NCR Plus bubble. The efforts of the government and the skills of our medical frontliners were continuously tested. Why is it that there exist COVID-19 variants? Viruses constantly change as they undergo mutation. Just like the new variants of SARS-CoV-2, coronaviruses are known for their crown-like spikes on their surface. Scientists continuously monitor the changes in the virus, such as the structure and the genetic sequence. Mutations can lead to different changes in the virus, as it can affect the rate of infectivity and transmission. Some new variants of SARS-CoV-2 include B1351 variant from the South Africa, B117 variant from the United Kingdom, and B3 variant that was first detected in the Philippines. The contagiousness and transmissibility of COVID-19 and its variants also pushed the healthcare system and led to building more heal as one places. Let us have a problem related to this. Suppose that two buildings are constructed as isolation sites to house the COVID-19 patients. Their heights are 34 meters and 29 meters respectively. The government plans to put a connecting bridge from the top of the shorter building going to the other building. If the distance between their tops is 13 meters, how long is the connecting bridge? As part of step 1, the given information that we can use to solve the problem are the heights of the building, which are 34 meters and 29 meters respectively. In addition, the distance between their tops is 13 meters. What is the length of the connecting bridge? Let us continue and have its illustration. Suppose that here are the two buildings that were constructed for COVID-19 patients. Their heights are 29 and 34 meters respectively. The distance between their tops is 13 meters. We are asked, how long is the connecting bridge? Before we determine the formula to be used, let us analyze the given problem. We should take note that the length of the taller building is 34 meters. Let us draw an imaginary red line on the top of the shorter building with a height of 29 meters. Considering the perspective of the taller building, the height from the ground to the red line is the same with the height of the shorter building. That is 29 meters. What is the height of the remaining portion of the 34-meter high building? Did you answer 5 meters? What a great critical thinker. You are correct. If you will get the sum of the partitioned heights, it is equal to 34 meters. If we take a closer look, a right triangle can be formed, with the sides 13 meters for the hypotenuse and 5 meters for one of the legs. With the known information and a leg which is a missing side of the right triangle, we can use the Pythagorean theorem. Let us solve for the unknown. How long is the connecting bridge? Let us represent the length of the bridge as b. Using the Pythagorean theorem, substitute the values. We will obtain the square of 5 meters plus the square of b is equal to the square of 13 meters. Squaring the terms will result to 25 square meters plus b squared is equal to 169 square meters. Applying the addition property of equality, we add negative 25 square meters to both sides of the equation. Thus, we obtain 169 square meters minus 25 square meters is produced. Combining the terms, we'll now have b squared is equal to 144 square meters. To get the value of b, we need to extract the square roots of both sides of the equation. Taking its positive root, we can now have the final answer, b is equal to 12 meters. To answer the question on how long is the connecting bridge that will be used to link the two neighboring hospitals is 12 meters long. These are only some of the real-life examples where right triangles, specifically Pythagorean theorem, is applied. I hope that you can still follow on the topics that we are discussing. Let us continue. Problem number 4. In your backyard, you notice that a tree and a seedling cast shadows at a certain time of the day. You remembered your math lesson about triangle similarities and make a mathematical investigation on how to get the height of the tree. If the tree casts a 24 feet shadow, while a 3-foot seedling casts a 2-foot shadow, how high is the tree? In the problem, we are given with the length of the shadow casted by the tree and the height of the seedling together with the length of the casted shadow. Let us analyze and draw an illustration for the given problem. Based on the given information, the tree casts a shadow of 24 feet, while a 3-foot seedling casts a shadow of 2 feet. We are asked to find the height of the tree. From the illustration that we made, we should take note that the rays made from the sun are parallel. Considering the parallel lines and the ground as the transversal, as shown in the figure, we can form congruent angle pairs known as corresponding angles. As stated in the postulate, if two parallel lines are cut by a transversal, then the corresponding angles are congruent. Thus, we already have a pair of congruent angles. Also, the vertical distance or the height of the tree and the seedling form right angles with the ground, hence forming the second pair of congruent angles, since all right angles are congruent. Now, are the two triangles similar? Why? That's correct. Using the AA similarity theorem, the two triangles are similar. Since the two triangles are similar, we can make a proportion out of the ratios of their corresponding sides. The ratio of the height of the tree and the height of the seedling as 2 or equals the ratio of the length of the shadow made by the tree and the length of the shadow made by the seedling. So this is the proportion. To continue, to know how high is the tree, we represent its height by h. Substituting the values to the proportion that we formulated, we have the ratio h over 3 feet equals the ratio 24 feet over 2 feet. By cancellation, we cancel the units feet. Getting the lowest term of 24 over 2, the result is h over 3 feet is equal to 12 over 1. Using the means and extremes theorem, or the fundamental theorem of proportion, h times 1 is equal to h. 3 feet times 12 is equal to 36. Hence, we obtained h is equal to 36 feet. After solving, we are now ready to answer the question, how high is the tree? The tree that casted a 24 feet shadow is 36 feet high. Speaking of shadows, let me have another bits of information. Did you know that recently we experienced a scientific event? This happened last April 29, 2021. Last April 29, 2021, we experienced the Zero Shadow Day. It happens twice a year when the sun crosses the local meridian or is directly overhead or in the zenith of a specific latitude. The sun rays will fall exactly vertical to the objects at the ground, casting no to very little shadows. The Zero Shadow Day in Manila, Philippines happens every 29th of April and 13th of August yearly. So the source of this one is Earthshakers Philippines. This day is indeed a fun-filled trivia day. Hopping to another bits of trivia, do you know what is this? According to the National Geographic, a geyser is a rare kind of hot spring that is under pressure and erupts, sending jets of water and steam into the air. Now, let us use this geyser as we discuss problem number 5. One places a mirror on the ground 45 feet from the base of the geyser. He walks backward until he can see the top of the geyser in the middle of the mirror. At this point, he is 7 5/10 feet from the mirror and his eyes are 6 feet above the ground. Find the height of the geyser. In the problem, we can use the following information about the distance of the geyser and one from the mirror as well as their heights. From this, let us have our illustration. Using the given information, it is stated that 1 is 7 5/10 feet away from the mirror so that he can see the top of the geyser in the middle of the mirror. Also, his eyes are 6 feet above the ground. On the other hand, the geyser is 45 feet away from the mirror. We are now asked, how high is the geyser? Let us have some sort of an overview about the property of a plane mirror. According to physics, when a light is reflected from a mirror, it bounces off at the same angle in the opposite direction from which it hit. Hence, we can form pair of congruent angles as shown in the figure. Before determining the formula that we need to use, according to physics, we can form two congruent angles when light is reflected from a mirror. Another, the vertical height of the geyser and one's eyes form right angles with the ground. What triangle similarity theorem can we use to prove that the two triangles presented are similar? That's great! The two triangles are similar because of AA similarity theorem. Since the two triangles are similar, then we can form a proportion out of the ratios of their sides. We can use the ratio of the height of the geyser over the height of one's eyes as 2 or equals the ratio of the geyser's distance from the mirror over one's distance from the mirror. At this point, after formulating the proportion, we are now ready to solve for the unknown. Let us represent the height of the geyser as the variable g. Substituting the values to the proportion, we will obtain g over 6 feet is equal to 45 feet over 7 5/10 feet. Using the cancellation property, we can cancel the units used. Then, simplifying the fraction, the result will now be g over 6 feet is equal to 6 over 1. Applying the means and extremes theorem or the fundamental theorem of proportion, g times 1, that will be g, is equal to 6 times 6 feet, which is equal to 36 feet. Hence, the value of g is equal to 36 feet. Finally, to answer the problem on how high is the geyser, the answer is the geyser is 36 feet high. I hope that you are enjoying our discussion for today. The last two problems discussed previously dealt on triangle similarity. We are now down to the last example. But before we go to that, did you know why the Philippines is prone to tropical cyclones? According to Pag-asa, the Philippines is prone to tropical cyclones due to its geographical location, which generally produce heavy rains and flooding of large areas, and strong winds, which result in heavy casualties to human life, and destructions to crops and properties. Tropical cyclones can only form over oceans of the world except in the South Atlantic Ocean and the Southeastern Pacific. In relation to these, the top 3 deadliest cyclones that hit the Philippines are as follows. Top 3 is Uring, with an international name Telma. It happened in November 1991 that has more or less 5,100 fatalities in Leyte. Top 2 in the list is Yolanda, with an international name Haiyan, a Category 5 super typhoon. It happened in November 2013 that has an approximately 6,300 fatalities. It is also considered as the costliest typhoon that has a damage yielding to 95.5 billion pesos. The highest in the rank and said to be the deadliest typhoon that ever hit Philippines is Typhoon Haiphong. There were approximately 20,000 fatalities that happened in October 1881. As early as this month, different agencies in the government are preparing for the climate type 1 or the rainy season. This picture shows the police department in Manila having their training in search and rescue along the coastline of Paseco in Manila. The picture was taken from the FB page of the Philippine Star. As the dry season is about to end and the rainy season is about to come, we should always be prepared with the things that we need in case of disasters like typhoons, landslides, and flash floods. Problem number 6. Rainy days are soon to come. In preparation, your father decided to put metal supports in your roof that will be put perpendicularly from the vertex of the roof to the ceiling. If your roof has a cross-section that is a right angle as shown in the figure, how long is each of the metal support that will be put? The problem is already illustrated, and the given information are also indicated. With this, let us proceed to step number 2. Before determining the formula to be used, let us analyze the problem and illustration. We are asked to find the length of the metal support that will be put perpendicularly as shown in the figure. Since the figure shows a right triangle with an altitude from the vertex of the right angle to the hypotenuse, let us use the special properties of right triangles, geometric mean to be specific. Let us represent some variables to each given measures of the sides of the right triangle. Let A for 7 meters, B for 24 meters, and C for 25 meters. This will help us to easily formulate the formula that we will use later. Let us represent the altitude to the hypotenuse by the variable y. And one of the segments formed in the hypotenuse, let us represent it as x, as shown in the figure. Since the hypotenuse measures 25 meters, we can say that the other segment in the hypotenuse measures 25 minus x. We cannot use special property 1 of right triangles because there will be 2 variables that we need to deal with. So, let us use the second property of right triangles, since the legs of the bigger right triangle are given. It states that each leg is the geometric mean between the hypotenuse and the segment of the hypotenuse adjacent to the leg. Using special property of right triangles 2, each leg So the leg that we are to use is this one, or A. So A equals, it is equal to the square root of the hypotenuse, which is C, times the length of the segment in the hypotenuse adjacent to leg A. So that is X. Hence, the equation that we will use is A is equal to square root of C times X. Now, let us solve how long is X. We can find how long is X by substituting the values to the formula, obtaining 7 meters is equal to square root of 25 meters times X. To solve for X, we need to square both sides of the equation. Squaring the terms will result to 49 square meters is equal to X times 25 meters. Next, we need to divide both sides of the equation by 25 meters to get the value of X. By cancellation, X is equal to 49 over 25 meters. To get the value of Y, you may use the Pythagorean theorem or the geometric mean in the altitude of the right triangle. In this case, let us use the special property of right triangle in getting the length of the altitude. We first solve for the length of the other remaining segment given by 25 minus X. Subtract 25 and the value of X that we got, which is 49 over 25. By the use of the LCD, that is 25, the result is now 625 minus 49 all over 25. Simplifying the equation, the length of the other segment is 576 over 25 meters. Since we already know the length of the segments formed in the hypotenuse, we can now find the length of each metal support needed, or the variable Y. We use the property, the measure of the altitude is the geometric mean between the two segments made, represented by the yellow and the blue segments. Or Y is equal to the square root of 576 over 25 meters times 49 over 25 meters. Simplifying the equation, it will result to Y is equal to the square root of 576 over 25 times 49 over 25 times square meters. Let us extract the square roots of the factors separately. Getting the square root of 576 over 25, that is correct, 24 over 5. Getting the square root of 49 over 25, very good, it is equal to 7 over 5. And finally, getting the square root of m squared, or square meters, the result is absolutely, it is equal to m. By multiplication, we can say that the length of Y, or the metal support, is 168 over 25 meters, or 6 and 72 hundredths meters. Hence, to answer the question, how long is each of the metal support? Each metal support measures 168 over 25 meters, or 6 and 72 hundredths meters. What a day! We've encountered problems that we are unconscious that we can apply mathematics, especially in triangle similarity and right triangles. Let us sum up today's discussion. In solving problems involving triangle similarities and right triangles, we follow some steps to make our solutions organized to come up with the correct answers. After reading and analyzing the problem, here are the steps. To remind you, step number 1, identify the given information and illustrate the problem. Number 2, determine the formula to be used. Step number 3, solve for the unknown in the given problem. 4, state the final answer. Remember, answers must be in complete sentence and with appropriate units. We often encounter problems that test our strength, resiliency, and even our faith. Don't ever lose the hope and the fact that these problems that we encounter will always bring out the best in us. Discover that we can do better than the best. Problems have different ways and approaches that we can apply just to solve and find the answer. Do plans, execute, try, rest, go again. It is believing in the cliche, mind over matter. This is Mr. Jude M. Pilapit, your Mathematics 9 live streaming teacher for today. Stay safe, God bless, and good day.